Another piece of evidence for this northern migration of severe convective thunderstorms is that for the first time in 2010, Minnesota led the nation in number of tornadoes. We had 113 documented tornadoes in 2013. Illustrated on this map is the fact that we had 48 in one day, namely June 17th of 2010. 48 tornadoes, a rather busy day for the National Weather Service. We also use our data from Environment Canada. Our friends in Environment Canada help us document this as well. And illustrated on the upper right here is the first ever F5 tornado documented over Manitoba, namely Ely, Manitoba, back on June 22nd, 2007. The Canadian provinces up till 2007 had never had the convective thunderstorm attributes to powerfully produce a complex of storms that would lead to an F5 tornado, 260-mile-an-hour winds or greater. And for the first time in Canadian history, that occurred in 2007. And finally, another piece of illustration evidence from our friends in Canada is in the lower right here, where we document up at Churchill, Manitoba on the Hudson Bay, an area of permafrost located 59 degrees north latitude, where many tourists go to watch the polar bears play. Back in August of 2010, they had cloud tops to 48,000 feet elevation, never before seen in that landscape before, and they had a 4-inch thunderstorm rain, the largest single-day quantity of thunderstorm rainfall ever measured at 59 degrees north latitude. And please bear in mind that that rain fell on permafrost. Another piece of evidence is the erratic climate behavior associated with this change in severe and extreme weather. And no better illustration of that exists than the summer of 2012, which is illustrated, color-coded here with a slide from the summer in 2012 across Minnesota and western Wisconsin. The color-coded counties depicted here in orange and red are the counties that were declared by the USDA to be federal drought disasters due to severe or extreme drought. And in those landscapes, there was water rationing, there was crop loss, there were suspended well permits for irrigation. All of the symptoms of drought were in play, declared by USDA, all those counties eligible for federal drought assistance. The plus signs designated over the top of those counties were another more distinct declaration from FEMA that all of those counties were eligible for flood disasters. Flood disasters in the same county that had declared drought disasters. So if you will, polar opposite federally declared disasters, both allowing those counties to petition for federal relief and federal low-interest loans, but for polar opposite climate reasons. That's the first time in Minnesota state history that this has ever happened. And this is an illustration of how erratic the climate behavior has become. Coping with that, of course, is another challenge illustrated here by the hydrograph sequence from the St. Louis River in northeastern Minnesota, which was subject to its all-time record flood crest due to the massive flash flood that occurred in June of 2012 over that part of the landscape, delivering up to 10 inches of rainfall to Duluth in a 12-hour period. The flow volume on the St. Louis River in that part of Minnesota spiked in the lower right hydrograph here at 45,000 cubic feet per second. A volume of flow on the St. Louis River that is analogous to the upper Mississippi at flood stage. That surpassed all previous record flood crests on the St. Louis River, dating all the way back to 1908. That was in June of 2012. Remembering what was illustrated on the previous slide, which was drought, by the time drought had had its effect on that area of Minnesota in November of 2012, roughly 5 months later, the volume flow on the St. Louis River was 458 cubic feet per second. I would remind you 5 months earlier it was 45,000 cubic feet per second. In November it was 458 cubic feet per second, 90-fold less. So in an all record encompassing examination of the St. Louis River, which dates back to 1908, the volumetric flow record on the St. Louis River shows the two most extreme data points, highest crest, lowest volume, separated by 5 months. Another measure of what extreme weather can do to erratic climate behavior on the landscape. In summary, the changes in precipitation and extreme weather have, like temperature and dew point, led to measurable consequence. We see changes in the biology that we observe on the landscape in terms of diseases, in terms of microbiology, in terms of insects and parasites. We see changes in the moisture-driven exposures to molds and allergens. We see adjustments to irrigation. We see adjustments to drainage. We see shoreline management with the extreme rainfalls we've been getting. We see retrofits of storm sewer runoff systems so they can handle higher capacity storms. We see mitigation of flood potential on many of our watersheds to try to become more resilient in coping with the high volume flows. And we see changes in insurance rates and the way that we have to pay for, if you will, the consequences of these changing climate features. Lastly, and in conclusion, the common ground we have in dealing with climate change is to remember that it's affecting things we care about. The reason climate change is an important science issue, the reason it's deserving of our attention, is because it's affecting things that we value. And you can contemplate that for yourself. This is just an example that many other audiences have provided to me as a climate scientist. This is a topic well worth your attention. It's a topic well worth studying. It's a topic well worth having a dialogue about with your fellow community citizens. And that's where I'll leave you. Thank you.